These are the introduction to that means content of your AXA protocol we have discussed already, and what is AMBA and why it is used. I told you that what is AMBA. AMBA is a open standard uh, protocol. Okay, open standard protocols it will support that, and then open standard means there is no fee we need to pay to get the license. Okay, so we will get the protocols freely. So that is the open standard specification protocol. And then on-chip interconnect specification is developed by ARM only. And then why it is AMBA is used means so open standard and royalty free and used for billions of ARM-based SoCs. Okay, based on that it is used, and different AMBA protocols we are using AXI, APP, HBAs, and TIE protocols. These are the architectures in AMBA interconnect architecture here, and then how AMBA works. So master initiate the transactions, and arbitration will take care of the which master is communicating with which slave, and then address phase. During the address phase, master will put the address into the slave. After the data phase, it is transferred the data from the master to slave or slave to master, and response phase we are getting the response from the slave. Okay, and then multiple outstanding transactions it will suppose. Multiple outstanding transactions means one master have multiple transactions. Okay, so one transaction after that other transaction will be completed. Up to that remaining transactions will be wait on the queue. These are the benefits, benefits like high performance, modular on the scalable, after that reusable and standardized, low power options, wide adaptations, and then key benefits. We have already discussed in the previous class, right? So this is the AMBA evaluation. How APB 3, 4, 5, so APB, APB 2, 3, 4, 5. So how it is evaluated, and then what are the features we are addressing here. Okay, what are the features we have added that will be addressing in that slide. And this is the SOC bridge. So how real-time SOC is connected different protocols, and then see all the peripherals are connected, and then processing system is connected, interconnect we are connecting, as well as the application process unit we are connecting, and then programming logic devices all are connected different protocols. Okay, high speed interface we are connecting, high speed bus we are connecting, and then what else, low power signals we are connecting. All these signals are connecting through different protocols. Okay, so this is about introduction to AXI protocol. AXI Advanced Extensible Interface. It is a high performance, high frequency, and then burst-based transactions it will support, and then low latency will support, and then scalability, flexibility, and reliability. All these are the features of your AXI protocol. Okay, AXI protocol can support uh, faster high performance devices to low speed peripheral devices, or then some different peripheral devices like slave devices like memory devices, and then peripheral devices, registers, and other slaves. Okay, multiple masters can access that multiple slaves. So these are all multiple masters: CPU, DMA, GPU, other masters. All are multiple masters. Multiple masters can also connect with multiple slaves. So AXI protocol layers, application layer, AXI protocol layer, and then interface layer, physical layer. Application layer is a user-defined layer. That is a software. Okay, any software we are implementing. And then AXI presentation layer. Okay, sorry. Protocol layer. Protocol layer means in that protocol layer it is doing that write read operations, and then write transaction, read transaction, all are doing here. Okay, handshake mechanism is happening here, and then AXI interface layer. Interface layer means different channels and then timing signals. Okay, so channels means read channel, read address channel, write address channel. All these channels will take care of this AXI interface layer. And then physical layer, it will transfer the communication between the different layers. Okay, AXI protocol family like AXI, AXI4 Lite, AXI Stream, and AXI5. Okay, all are same, but it is improved versions. AXI3 to AXI4 channel length is increased. AXI4 Lite low complexity we are implementing, and then AXI Stream combining all the signals while video processing, and for that we are using. And AXI5 some quality of service and atomic operations are implemented. So this is what somewhat extension of the previous protocols. So previous protocols are also supporting for the present protocol. Okay, AXN5 we are using quality of services. Then these signals are also useful as well as it is also compatible with the backward versions. Okay, so it will also support that. And then these are the key characteristics, five independent channels, every channel having read or write channels. Read or write channel means that is a handshake mechanism. Based on the handshake mechanism only we are transferring the data. And burst transfers, and based on the configurable length and size, multiple outstanding transactions using ID, and then out of order transaction, out of order completion, byte lane. So out of order means one slave can respond in any order, right? Suppose you are doing you are transmitting images, okay? So to your friend, in that whatever the highest size image is there, that will take more time. What are the less size images there? You are sending 10 images in WhatsApp. So first image you selected some highest memory size, and then last image you selected that low memory size. Then last image sent first. In between that, based on that, it will support out of order transactions, and then provides quality of service, protection, catchy attributes. Protection it will some locked access and exclusive locked access it will support that. And catchy attributes means who is connecting to which slave, that will support the catchy attributes, and then supports both memory map and streaming data. Okay, all these are related to AXS.
And what is bus transfer?
Burst transfers means you are initiating single address. Suppose you are initiating 1x000. Okay, so 1000 you are initiated this address. Then based on the length and size, it will increment automatically the next size. That means 0x1004. After that 0x1008. So based on that your burst length and burst size, so the next address system only calculating based on the burst transaction. Burst means single address you will initiate it. Based on that multiple data you can transfer. Okay. So this is the AXA protocol architecture. Okay, in this architecture, what we are doing means so multi-layer architecture. Okay, AXA uses that multi-layer architecture, and it connects multiple masters to multiple slaves using interconnect. See, master 0, master 1, master n masters are there. Okay, using that n masters, we are connecting n number of slaves, slave 0, slave 1, slave n. Okay, so here point to point communication is possible, and then cross multiplication is also cross connection also possible. Master 0 will connect with the master n, slave n, and master 1 also connect with the slave 1 are also connecting possible to slave 0. Okay, that cross connection is also take care by this interconnect, AXA interconnect, that is called abbreviation. We are taking care of that. And then optional components like a protocol converter, and then data bit converter, clock converter. So one clock is connected to other clock while we are using some bridge type of AXA protocols. At that time we need some clock converters and then data bit converters. See, AXI4 to AXI4 Lite we are connecting. So at that time we need a converter. Okay. See, five channels are there. AW channel, that means write address channel, write data channel, okay, write response channel, read address channel, read data channel. Okay, all these five channels are different channels. It will suppose that each and every transfer, all these five channels are taking place. Okay, so write address channel. What it carries? That carries address and control information for your write transaction. Whatever you are doing the write transaction, that means master to slave, you are doing that write transaction. At that time, you are this is carrying the address. Suppose 0x1005. This is the start address you are carrying. So this address, how much data it is carrying, that width is defines that, and then depth is defined. So width and depth, that will defines that how much data you are carrying there. Okay, so width means suppose AW address having AW address channel is there. Okay, that is depends upon the width minus one. Okay, so width minus one down to zero. That means your width is 32 bit. So 32 bit minus one down to zero. That means 31 to zero. So that means what is that 32 bit address you are sending there? That control information also carries this AW channel, write address channel. Clear? So what are the signals we are having? AW address, AW length, AW size, AW burst, AW ID, AW valid, and AW ready. Valid, ready, ID, size, length, address, all these are every channel we are having. Okay. So here write address you are take calling, then AW is the notation of your write address channel. Like how APP signals we are representing peripherals P. Okay, P is the common notation. Similarly, AW address. So write address we are using AW. AW is the common notation. Similarly, write data. Write data carries that write data from master to slave. Okay, this is your master. Okay, my master is any CPU. CPU is my master, and then my slave is UART. Okay, from CPU to UART we are communicating. At that time, it carries some data 0, data 1, okay, data 2. So this data will carry it throughout this write data channel. Okay, through write data channel from master to slave, we are keeping the data. Okay, and then write response channel. So write response channel, it will carry the write response from master, slave to master. Okay, slave is the UART, right? UART is the slave. After sending the data from master to slave, this slave will respond to this master. Okay, it will send some response. Okay, response it will send. Okay, I have received the data. In that way, it will send the okay response to this. So through using write response channel. Okay, write response channel from slave to master. So B response, B ID, B valid, and B ready. B response is the signal. Through this signal only the slave will respond to your master. And ID, that means which data you are responding. First data, second data, nth data. So we need to know that which data you are getting the response. Based on the ID, we will know that. Okay, so my first data is completed, and I got the response from the slave. So in that way, based on the ID, we will note that. And read address channel. Sorry, read address channel. Read address channel, it is also carries the address and then control information from the read transaction. It is similar to write transaction, but reading means the UART is sending data to the CPU or DMA or GPU. Okay, so master slave to master. Okay, slave is sending this data 0. Okay, data 1. Okay, so all these data are sent by the slave. Okay, so different data are sending here. Okay, data 0, data 1, data 0, data 1, 2, 3. In this way, it will send the data. Okay. So this is layered architecture. Already we have seen in the previous slide. Okay, layered application layer, that is the user generates the layer. What you are doing, some read operation, write operation, it will request that. And then AXA protocol layer, what it is doing that. So it will take care of the transactions. Is that out of order transactions is supporting or outstanding transactions or it is doing or any locked access are we are doing. Okay, all these take care by AXI protocol layer. Okay, AXI protocol manages the transaction and ordering. After that, AXI interface layer. Interface layer channels and signaling and timing. That means five independent channels we are having: read address, read data, write response. Okay, so all these five channels we are having different timings. Okay, timings and different signals are passing. That will take care by this AXI interface layer. And physical layer, it will connect that. So electrical signals it will convert to electrical format of the signals. Whatever the signals you are transferring, those signals will be converted into electrical signaling. So because it is a physical medium between the transmitter to receiver, that means master to slave. How the right transaction flow it will happen? It will this is the my master. Your master is maybe DMA, okay, and your slave is maybe some SRAM. Okay, so here we are doing write transaction. That means DMA initiate that address through address channel and then configure also. After that, it is sending address to your slave. So particular location it is accessing that, and then it is storing the data in that particular location. This is the address location I am operating like 0x 20052 and 07FFF location I am doing the right transaction. Okay, this address location we are doing the right transaction, then it is stored the data. After that, the slave will respond. That means SRAM is sending the response to master. Okay, so similarly, see three phases we are following: address phase, data phase, and response phase. Address phase we are keeping the address. In the data phase we are uh, transferring the data from master to slave. And then response phase, slave will respond whatever the data you are sending, that data is received by the master. Okay, so the master is sending the data and slave receives that. Then slave need to respond accordingly. What type of data you are receiving? Okay, then only master knows, okay, my data is received by the slave successfully. And then read transaction. We are keeping the address only. And then data. So during the data only we are receiving response channel. Okay. So there is no separate response channel for the read transaction flow. Why it is not there means, see, this is the reading the data, right? So based on that reading data, it is sending that response also. Along with the read data, the response also sending by the slave. So that is why there is no response channel, separate response channel is there in AXI protocol. So read, write, address and data paths are there. That is the full duplex operation. Full duplex means master can transmit the data and slave can also transmit the data. Both are reading and writing, both are happen parallelly. That is the in full duplex transfer. And five independent channels maximum throughput we are transferring. That means each and every one transfer communicating independently. Okay, and then highly pipelined with supports multiple outstanding transactions. Multiple outstanding transactions means from master to slave, you are sending multiple data. Okay, so data 1, data 2, data 3. So in this way, we are sending the data. So here one queue is there. This queue will take care of that waiting in a queue. So because one transfer is completing, next transfer will take place. Okay. So based on that, multiple outstanding transactions will be supported here. And then ID-based transactions for out-of-order completion. I told you that out-of-order completion means master will send multiple masters can communicate with multiple slaves. Okay, so master one is communicating with slave one, master two is communicating with slave two, master two is communicating with slave one, master one is communicating with slave two. Okay, based on this master 1, master 2, and slave 1 and slave 2. So based on that, um, here master 1 is communicating with slave 2 and master 1 is communicating with slave 1. The slaves, both these slaves can respond in any order. First I am getting the response from the slave 1. After that is getting the response from slave 2. Okay. So, but initially I have initiated the transaction with slave 2, but we are getting the response from the slave 1 because slave 1 is the faster slave 2 is the slower slave. Okay, based on that we will get the response. And then interconnect enables scalability and flexibility. Scalability means it is also supports large complex SoCs we are supporting. Okay, large complex SoCs, that means system on chip we are connecting, and interconnects enables scalability and flexibility. How many slaves we are communicating, so that will scalable, and flexibility also which slave we are communicating with which master. Then there is no problem in that it will communicate it. Okay, modular architecture and suitable for soft designs. So these are the key characteristics of AXA protocol. This is the architecture we told you, right? And then use benefits high performance softs, and then benefits high throughput. So used in mobile processors, and then FPGA systems, AR and accelerators, automotive systems, and network and equipment. Mobile industry we are using everywhere, and then AI tools. For the AI tools, how the faster transmission data will be taking place. So at that time AXA protocol we are utilizing, and then automotive systems in cars, and then wipers, all these things. Automated, fully automated cars are getting, right. So based on that we are controlling that wipers, and we are controlling the steering, and we are controlling, so all these things are happening. And the benefits, so throughput is high, latency is low, scalability, flexibility, reliability, power efficiency. Low power is consuming, more reliability. So that means once we design that, we will use the long lifetime. And then flexibility, who is connecting, who is disconnecting, there is no problem in that. So anyone can connect, anyone can disconnect anytime at any place. And scalability means during large talks also we are measuring that how many devices are connecting, which are communicating, which are not communicating, that will scalable. Low latency means high speed, high throughput, that means there is no delay, less delay we are seeing. So this is the architecture summary. Okay. So five channels we have. Okay, it's a having five different channels. Okay, so what are those? Already I have explained write address channel. What is doing here? Write address channel carries the address and control information. Okay, and then write address channel from master to slave. What is the description of the write address channel? So master sends the write address and control signals to slave. It indicates that where data will be written and how write should be handled. I told you that. Okay, this is the master and this is the slave. Okay, your master is maybe CPU or GPU, anything, and your slave may be SRAM and GPIO, UART, I2C, all these things. Okay, which location you are sharing the data? We need to know, right? So based on that, master is sending the address. Based on the address, okay. So you are staying. So suppose you are staying in which place? Okay, which area you are staying? So based on the address only we will know. Then only we will get the data from that location. So that will be controlled by the AW address channel. And then main signals are what are that AW address. That means write address channel. And burst length and burst size. AW length and AW size. And then AW burst. So burst type either increment burst or fixed burst and rapid burst. It is a 2-bit burst, and then burst size is 3-bit, and then burst length is also 4-bit. Okay, and then AW catchy. So catchy type, which one it is storing the data, and then protect signal. Protect signal it will also support that secured, non-secured, all these things will support that, and handshaking signals. W and valid. Each and every channel we are having valid and handshaking signals. Sorry, valid and ready signals. These are handshaking. Then only we will communicate between the master and slave. So when transfer is happens, so transfer occurs when AW valid and AW ready. So master will send the valid data and slave will send that I'm ready to receive the data. So then both the signals are one, then only sampling will be happen. Otherwise sampling will not be happen and we are waiting state only. Okay, and then W write data. How the write data is carries that. So write data carries that data from master to slave. So previously we are keeping the data from master to slave. So how we are keeping? We are keeping the address. Based on the address, the data channel will send the data in that location. Okay, wherever the address you are keeping, that address location, we are sending some data. Okay, so master sends the actual write data to the slave. Suppose burst data. I told you that burst data, single address we are initiating, single address we are giving. Based on the single address, multiple data are transferring. Okay, multiple data are transferring. That is the burst based transaction. What are the common signals or main signals we are using in write data channel is W data. W strobe. This strobe is which byte lane we are having the valid data that will tells you. Okay, right strobe signal is tells you you are sending 32-bit data. So 32-bit data means 4 bytes we are sending the data. In that 4 bytes, which byte lanes we are having valid data. That will tells you this right signal, and then W last. So W last means right last signal. Okay, so last signal that means last bit of transfer we are having at that time. This last signal will be high. Okay, so you are sending 10 data, one first data sending, and then 10th data. So after the completion of 10th data, this last signal should be high. That means your transaction is completed. It will indicate that your transaction is completed. Okay. So how transfer occurs? When valid, that means W valid master should be one. See, each and every channel valid and ready signals are there. So then only the data will be transferred. If the ready signal and valid signal should be one on clock cycle. So this is valid and this is ready, and the same cycle we will get the valid and ready signal should be high. Then only handshaking is happening, and then write response channel. So write response channel is indicated with B. Okay, carries the write response from slave to master. Slave will send that. Okay, I have received the data. Okay, your master is your DMA and your slave is SPI. Okay, so this SPI will send the information to DMA. Okay, I have received the data successfully. So that will indicate that right response channel. Okay, master sends the actual data. Sorry, after slave receives the all right data, it returns to response, indicating that success or failure of your data. Once master is sending all the data from slave to master to slave, then slave will respond that. Okay, I have received all the data successfully without any loss. So this is the signal B response signal. We will get the right response signal. It is a 2-bit signal. And B valid, B ready signals are also common. Okay. When transfer occurs, both the valid signal and ready signal should be one. Then only the transfer is occur. Okay. AR address channel. That means read address channel. This is also carries the information as read transactions. Okay, so how AW address is transfers carries the configuration control information as well as write transaction in the read write transaction, right? Same way, read address also carries that read transaction as well as some control information. Okay, So this is the AW address channel, right? Address channel from to slave we are getting that. So read address channel we are placing master. Master is placing the address. Then according to that, the slave will respond that. Slave will send the data through the read data channel. Okay, read data channel carries the data from slave to master. Okay, so this is the data channel. Slave returns the read data to master and supports that burst data transfer because AW address also supports that burst transaction. AW so AR read data channel also W data, that means AXA channel W channel, that is write data channel is also supports that burst transaction, and read data channel also supports that burst transaction. So what are the common signals in read address channel? Same AW address is there, right? Similarly, AR address. AW length is there, right? AR length. AW size is there, right? AR size. Okay, whatever the signals in write address channel, same signals will be there in read address channel. Okay, and then AR protect, AR valid and ready. So both valid and ready should be one only, then only the transfer will takes place. And read data channel, read response channel, R last and R valid and R ready. Okay, so these are the key points. We are having 5 independent channels, all are high performance channels. Read and write channels can occur simultaneously. Okay, any both are can happen simultaneously because independent channels are there. Okay, so you and me are connected independent channels, so we are having independent connection, and you and me are having independent connection, you and me are having independent connection. Okay, so based on that, see, like a group messages and then individual messages. We can also communicating with group and also we can communicating with individually. So based on that, virus transactions. And valid ready handshake is used for every channel. Every channel there is a valid and ready channels will be there. So based on this only we are communicating. The transfer is taking place successfully. Suppose burst transfers for high throughput. Okay, any doubt in this? So this is valid and ready. So how valid and ready will support here? Okay, see, handshaking concept. Valid shell should be accepted by your master. That means you are sending valid data, then valid signal should be high. So accepted by the source. That means AW or write or AR. Okay, so that means valid signal should be sent by write address channel, write data channel, read address channel, read data channel. Okay, so these are AW address, write address channel, write data channel, and then read address channel. So for slave will respond that D response or R response. When information is valid, then only we will get the response. I am sending the valid data, then you can receive the data. You need to give the response to me. So when I have sent the valid data, if I am not sending the valid data, you will also respond. So the failure of data, that is not valid data have received. Okay. So in that way we will get the valid signal response. Ready signal should be accepted by the destination, right? That means slave will accept that based on this. That means write address, write data, and then read address to master. Uh, how we are sending the response? D response and R response signals. When it is uh, ready to accept the data, you are sending valid data, then only it is accept the data, then ready signal should be high. When you are getting the transfer, see this is the clock signal. So the clock signal will be transmitting like this. So initially valid signal, this clock signal, valid signal should be high. Okay, after 3 clock cycles, valid signal should be low. We are maintaining. Before that, the next cycle ready signal will be happen. Okay, at this condition only. So this is the clock signal. this condition only sampling will be happen. Whenever valid and ready should be high, then only sampling will be happen. So there is no other transfers will be happen. See, these are the conditions. Valid signal should be 0, ready signal should be 0. There is no transfer. Okay, both are zeros only. There is no transfer here. And then valid signal will be 1, ready signal should be 0. See, valid is 1 here, but ready is not there. Then only it is also not happening the transaction. And then valid signal should be 0, ready signal should be 1. So here valid is 1 here, and then remaining cases valid signal should be 0. Here valid there, here valid is not, ready is not there. Here valid is not there, and here ready is there. This is also not true. Okay, at this condition also the destination holds the ready signal high until that valid signal should be high. So this condition also not happening the transfer. Okay, so here ready valid signal 1, ready signal should be 1. Both the conditions we are maintaining valid and ready, then only transfer is happening. Okay, this is the handshake mechanism. Valid must be high when the data, address or parole is valid. Okay, valid should be remain high until the transfer occurs. We need to maintain valid should be high, never goes to 0. So otherwise it goes to 0 means you are violating the protocol. Okay, and then ready can be high or low based on the destination control. Okay, destination controlling it. When I need to send the ready signal, if I receive the valid data, then only I will send the valid ready signal should be high. Once transfer occurs, that valid and ready signal should be high and data or address is accepted. You are sending some data from master to slave. Okay, so then the master is sending valid data, then slave will send the response to that. So then only transfer is happening. That at that time valid data will be happening in between the master and slave. Okay, do not depend any minimum pulse width or sampling occurs in the rising edge. Okay, so we are not depends upon the pulse width. Okay, this is 0 and this is 1. Okay, this is 0 and this is 1. Based on this, not depending on that. Okay, we every passage of the clock we are uh, accessing the transaction. So this is the passage clock. Again, next passage clock we are taking transaction takes place. Okay, the transactions or transfers will take place at every rising edge of the clock. All AXA5 channels are using the same valid and ready set mechanism because right address channel is having valid and ready, right data channel we are having valid and ready, read address channel we are having valid and ready, response channel we are having valid and ready. All the channels having valid and ready. Based on that only we are transferring the data. Okay, so that's what AXA valid and ready handshake ensures that reliable and flexible data transfer. When valid and ready high, the transfer is sampled on every rising edge of the A clock. Okay, clock we are using that is the uh, AXA clock. AXA clock is represented with A clock. Okay, this is the clock. A clock signal. Based on this only, I am getting the ready signal should be high. Okay, every passage of the clock we are uh, transferring the data. That means sampling will be happening. So these are the protocol key features. What are the key features we are having? So AXI uses to point transaction, point to point communication, it is possible. And then cross-bar switch also it is possible. It is taken care by the interconnect. Okay, cross-bar switch, that means master is communicating, one master, single master is there, and then slave 1, slave 2, slave 3, slave 4 communication is possible. Multiple master, multiple slaves are there means, so it is possible to communicate the cross-bar. Master 1 is all communicating with slave 3, master 3 is communicating with slave 1. In this way, the crossbar handles that. Interconnect or crossbar handles that arbitration and routing. Okay. There is no tri-state signals. Tri-state signals means high or low, we don't know that. So that tri-state signals are not there. So that means unknown or high impedance signals are not there in AXI protocol. Enables parallel communication or parallel connection and better scalability. Okay. So that is the point-to-point interface and high performance and high frequency design. I told you that. So it is a parallel transaction is happening and pipelined architecture for address and data phases. We are having generation of address and then address transfer and data transfer for one or more beats, and then we are getting the response. In the address phase, we are generating the address and transferring the address. In the data phase, we are transferring the data. In the response phase, we are receiving the response from uh, slave to master. So this is a pipeline operation. Overlapping phases are also there. Okay, one phase is overlapped with other phase also it is happening. And independent channels allows that parallel operation. I told you that each and every person have their own channel. Then they can talk immediately or later. It is possible. Okay, anything is possible because independent channels are there and supports deep FIFO and register slices for timing closures. Okay, it will store that multiple transactions are there means it will store in FIFO and then it will communicate the timing closure. It will close the timing closure also. Designed for high frequency system on chip designs. Okay, these are the key features we are having. And then high performance and high frequency design. High bandwidth and low latency. See, frequency and time period both are inversely proportional, right? If you are increasing the time means the frequency will be decreased. Okay, if you are decreasing the time means your frequency is increasing. Okay, decreasing the time means frequency increases means faster response, right? Faster response will be taking place. See, one address request can transfer multiple data. Okay, multiple data beats. Beats means one transaction, how many data we are transferring. Separate read write channels, so it is happening simultaneously. See, master is there and slave is there, write address channel is there, write data is there, write response is there. For read response or read channels also, read address is there and read data is there. Okay, parallel channels are there. Burst transfers will be supporting, based on that high bandwidth will be taking place. And then low latency. In small delay only, we are transferring the huge data. Okay, less overhead, few address bases, and more data transactions are taking place. And low latency pipelining and parallelism will reduce the waiting cycles. Okay, supports multiple outstanding transactions. Multiple outstanding transactions, see ID1, ID2, ID3. Okay, and then also out of order response. See, we can get the response in any order. Response 2 is getting first. After that, response 3, and then response 1. See, higher efficiency and better utilization of memory system is there. So, based on that, so the response may come in any order. That is the out of order response. Need to explain that. So, the slave can respond in any order. That is that out of order response. The master can issue that multiple requests and without waiting for the responses. And each transaction has an ID. Based on the ID, who can respond first, who can respond last, we will know that. Response can come out of order based on the slave readiness. Okay, based on the slave readiness only we are getting the out of order transaction. Ordering is preserved within the same ID. Okay, if you are sending same ID, ID1, ID2 and ID3, okay, both all requests are same IDs, all the responses will come in the same phase. Okay, so same whatever the ID we are having, same IDs can respond at the same time. If different IDs based on the slave, it will respond. So I told you that separate read-write channel, 5 independent channels are there. So this slide is repeating many times. Okay. So because this is the important channels, based on that only we are sending the data. Unaligned data transfers. Unaligned data transfers means, so if we are dividing the data with your burst size and burst length. Okay, based on that we are getting the data is aligned or unaligned. This strobe will defines that. Okay, right strobe signal which data lane or which data bytes are valid. So 1 indicates that valid and 0 indicates that invalid. Okay, so 1011. Okay, 1011 means beat 3 and beat 1 and then beat 0. So our byte 0, byte 1 and byte 3 are valid and byte 2 is not valid data. Okay, you are not written any data in that byte 2. Okay, so that will define this strobe signal. Okay, and then right strobe signal indicates that valid bytes and allows partial writes on the wide buses. Okay, wide range of buses. So all buses cannot read the cannot write the data here. Okay, so here byte 1, byte 2, byte 3 are there. So 1, 2, 3, 4 bytes are there. So if here I have written the data, here I have not written the data, here I have not written the data, here I have written the data. So based on this unaligned data transfer also it can support. Suppose all are having one means, okay, it is aligned because we have written all the data and you can send the data for all the bits of your bus. Okay, your bus is there. In that bus, all the data fields are filled. That is aligned data transfer. Why we are using aligned or unaligned data transfers means we need to use the efficient memory and register access. Who are having empty data, so at that time I need to write the data. Which registers are not having data, we are writing the data. Which registers are having the data, we are not writing into that data. So based on that, we know that okay. So the next transfer the B2 is byte 2 is not their data. We can store the data in that byte 2. So in that way, the aligned and unaligned data transfers will be supported. And then burst based transaction. See, address is there, then data are data 0, data bit 0, data bit 1, data bit 2 and on. So n number of data bits are transferring. That is the depends upon the burst length. Okay, burst length, how we will calculate it, it means suppose your actual length is 4 bits, it is given, then burst length we will calculate 4 plus 1, that is 5. Okay, so we need to add the plus 1 to your actual length. Okay, then only we will get the burst length. See, burst length is that n plus 1 beats. Suppose n number of beats you are transferring using your actual length, and then burst length you need to add plus 1 to that. Suppose 3 beats are you are using plus 1, then 4 beats of transfer is taking place. Okay. Different type of bursts are there: fixed burst, increment burst, and rapid burst. Fixed burst means entire transaction fixed address only sending. Only single address only we are using that. Same address for all beats of transfer. Okay. 10 beats you are transferring. All the 10 beats are same address. That is the fixed address. And then increment address means, so you are sending one address and it will increment automatically based on your burst length and burst size. Okay, see, C. After that 08. After that 1x 2000, and then 2x 0x 2004 08 0C F and 3000. So based on that, it will increment that. Address will be incremented. And then address wraps within the boundary. Okay, it follows that 4K boundary. Okay, so 4K boundary, maximum 4K boundary it is taking place. So based on the 4K boundary, if it is reaches that maximum boundary, and again it's wrap around to starting address. Suppose your address is 0x1010. Okay, so this is your address, and you calculated the wrapping address. So this is the start address. You need to calculate the lower boundary and upper boundary. So lower boundary, upper boundary, you need to calculate that. If you calculated the upper boundary, so, so you are having some last address. Okay. If it is crossed that your upper boundary means, then again wrap around to start address. Okay. So like a page. So you are starting from this page, and then entire data you have written after reaching the last line, and you need to wrap around it. And again you need to write from the start. Okay, that is the wrapping burst based transaction. After that, valid and ready handshaking flow is happening. AXI channels uses that valid and ready handshaking. So when you are having valid and ready, see this is the valid and this is ready. Then data D0 is supports here, and this is valid and this is ready. So data D1 is also supports that. And then data D2, here valid is there, here ready is there. Okay, so ready signal should not be there. See, every passage of the clock we need to check that. Okay, this is the rising end and this is the falling edge. So here data 2 is not happening. Here the data 2 is not there, so valid signal is not there here. Ready signal is not there. So based on that, data 3, data 2 is not transferring. Data 1, data 0 and data 2 are transferring. So whenever we are having valid ready signal should be high, then only the transfer is happening. See, these are the benefits of AXI protocol, AXI features: high performance, high bandwidth, low latency, scalable, reliable, and efficient use. These points are, you can say, everywhere: high bandwidth, high speed, low latency, and then high frequency, scalable, reusable, efficient memory use. All these points are common in AXI protocol. If anyone asks you to tell me the key features of AXI protocol means high performance, high bandwidth, low latency, scalable, reliable, and more efficient. So these points you can tell. And point-to-point communication is also supports that high-speed interconnect is there. Parallel read-write operations we are having. Burst-based transactions is supports that for high throughput. Multiple outstanding and out-of-order compatibility is there. Byte lane accessibility there. Unaligned transfers are also supports that. And then simple and efficient, valid and ready handshaking will be taking place. Designed for high performance system also. Here. These are the terminology. I told you that burst-based transactions. What it is doing allows multiple data transfers using single address space. Based on this single address space, we are transferring beat 0, beat 1, and so on. So beat n minus 1 based on your burst length. N number of beats we are having. Okay, so we need to transfer n number of transfers, and it is also protocol capable to calculate the next address automatically based on this increment, wrapping, and fixing. Okay, based on the burst types, the protocol will automatically calculate that next address. So benefits: higher bandwidth, lower address overhead, and then better bus efficiency use. Whatever the bus is idle, that will occupies the data. transactions. Transaction is a complete operation of AXI bus. Okay, AXI. It consisting of address phase, data phase, and response phase. That is the complete transaction. So address we need to keep that. After that, data we need to send, and then response we need to get. That is the complete transaction. So in this, write transfer is taking place. Write data transfer is taking place. Read response transfer is taking place. Okay. Based on that transfer, all the transfers are combined together, and then one transaction is happening. That is, write transaction is happening or read transaction is happening. Both the address phase, data phase, and response phase, all these three phases are completed means the full transaction is completed. Either write or read. Okay. See, transfer or beats. The smallest unit of data transfer on AXI bus, each transfer is 1 beat. 1 beat means, so this is the beat 0. This is one transfer. Okay. Beat 1 means another transfer, and beat n minus 1 means n minus 1 transfers will be taking place. All these transfers treated as one transaction. Okay. Transfer and transaction both are different. Transaction means for one person you are sending multiple data. That is one transaction. One data you are sending means that is one transfer. Okay. Each beat transfer can occur when valid and ready signal should be 1. Based on the valid and ready signal should be making high. Based on that only we are sending the data from master to slave or slave to master. See, burst length. Burst length defines how many beats you are transferring. Okay, so one transaction, how many bits you need to transfer? See, one transaction you are sending AW length and AR length is 3, that is your actual length. Then burst length you need to add plus 1. Then 4 bits you are transferring. That means these 4 bits will be treated as a one transaction. Okay, beat 0, beat 1, beat 2, beat 3, all beats are transferred. Then only one transaction is completed. Clear? So here will tell us that this is the transfer and this is transaction. All data are transferred, all bits are transferred. That is one transaction. So that is the AW length, and then actual number of bits is that AX length plus 1. AX length is nothing but AR length or AW length. Any length you can send. Write address length or read address length. So that should be plus 1, we can calculate the burst length. Okay, these calculations are important. And then burst size, number of bytes per beat. For one beat, how many bytes you are transferring? See, this beat 0, you are sending, suppose your burst size is 2. Okay, so your size is 2. Then burst size 2 power AX size. Okay, 2 power AX size means 2 power AW size. Okay, 2 power AR size. So AR size or AW size. See, if your AX size is 2, then burst size is 2 power 2. 2 power 2 means 4 bytes. 4 bytes per beat. In this beat 0, you are sending 4 bytes of data. Byte 0, byte 1, byte 2, byte 3. Okay. So byte 0, 1, 2, 3, 4 bytes of data you are transferring. That is tells about the burst size. Okay, burst length tells about you how many beats you are transferring in one transaction. Burst size will tells you how many bytes of data transferred in one beat. Then you can multiply this burst size and burst length, you can get total transfers. Okay, see, that is the burst transfers. So transaction calculation is depends upon the AW2 power AW size and AW length plus 1. This is the burst length and this is the burst size. Okay, based on that you need to know how many number of bytes per beat, that is the burst size will tell us about that. Burst length, the number of beats in one transaction, it will tell us that burst length. Okay. See example. So AX size is 3 and AX length is 7. Then burst length is 2 power 3 is 8 beats per 8 bytes per beat, and then AX length is 7, and then burst length is 7 plus 1 8. So 8 8 that means 64. So 64 bytes of data we need to transfer. So that means 8 beats we need to take that. Okay. Beat 0, beat 1, beat 2, beat 3, beat 4, beat 5, beat 6, beat 7. Okay, in this 8 bytes of data transfer, because 8 into 8, 64. Beat 0, 8 bytes of data is transferred. Beat 1, 8 bytes of data is transferred. Beat 1, 8 bytes of data will be transferred. Understood? So in beat 0, 8 bytes are transferred means one transaction is completed. Clear? Any doubt? So another example, see AW size is 2 and then burst length is 4, then number of beats is 5. So in each, uh, what is the number of bytes we need to send transfer? 20 bytes. Okay, 20 bytes of data we need to transfer. Okay, 20 bytes of data. So in this beat 0, beat 0, 4 bytes. 4 bytes means, so each, see, this is the AX size, 4 bytes of data. Okay, in this 5 bits, so 0, 1, 2, 3, 4. So based on the 5 bits, it will send that. Here, exact values are there. 8 bits, 8 bytes. Okay, then 64 bytes it will be transferred. Here, 5 bits, 4 bytes. In each byte, or sorry, each bit, 4 bits of data we need to transfer. Okay. So that is the complete write transaction will be happened here. Address we are sending byte beat 0 4 bytes, beat 1 beat 2 4 bytes, beat 2 4 beat 0 1 2 3. So 0 1 2 3. So based on that we will send the transfer. See total beats are 3 plus 1. Okay, 3 plus 1 means 4 bytes. Okay, and then total bytes are 4 into 4 16 bytes. Burst length into burst size. Then only the transfer is complete. Clear? So these are the key takeaways. Burst based transaction means multiple data are transferred using single address. You can say that. What is the burst based transaction? Based on the single address, we are sending multiple data. Transaction means combination of address space, multiple data bits, and response. Address, data, and multiple bits. How many bits are transferring? Then only transaction is takes place. Transfer or bit, smallest unit of data transfer. Okay, that is transfer or bit. Burst length, the number of bits. That means AX length plus 1. And then burst size, number of bytes per bit. Okay, 2 power AW's AX size. Okay, understand? And total bytes. Total bytes means that is the burst calculation. AW size, burst size into burst length. Then only you can know the total number of bits. Okay, that is the burst size we will calculate. So these are the big formulas. Okay, AW burst length. So burst length, AW length, AX length plus 1, burst size, A 2 power AX size, and then total bytes, that is burst size into burst length, and whenever transfer is occurs, valid and ready should be 1. Okay, so these are the common signals we are using. Benefits. Benefits all are same: high throughput, latency, battery utilization, reduced overhead, memory efficiency. Okay. fine. Study this